Good afternoon, everyone. Let's wait just for another 1 minute before we start the session. Thank you. So, good afternoon, ladies and gentlemen. Welcome to this webinar about Tiger Neo's performance, the financial and technical impact of N-type technology. This webinar is sponsored by Ginkgo Solar, the world's leading solar technology company, and we are proud to have a very experienced panel with speakers from Ginkgo Solar and Clenergize solar consultants. I'd like to also thank the Middle East Solar Industry Association, MESIA, for supporting this event. Our topic today is actually very special. Because of the rapid change in the PV market supply and prices, this led to the need to actually innovate in order to maintain and improve the profitability of solar PV while we live during these days of the highest polysilicon prices in the last 10 years. So I wish you an informative session and a lot of learning from our esteemed speakers today. Before we start, just a couple of admin topics. I'd like you please in chat and in the comments on social media to write me if you can hear my voice well and if you can see our screen, just to confirm that the voice quality is okay. And meanwhile, a kind reminder that if you have any questions, please don't send them in the chat box, but send them in the Q&A section in order for us to track these and be able to answer all of your questions today. Thank you for the comments. I can see that you can hear me well. If you can't join us through Zoom, then we are also broadcasting on social media, on LinkedIn, Facebook, Twitter, and YouTube, and the official Jinko Solar Arabia page on Facebook as well. My name is 𝗬𝗵𝗆𝗃𝗵, and I am from 𝗤𝗵𝗆𝗃, an engineer, 𝗤𝗵𝗃𝗃 is the biggest renewable energy platform dedicated for the MEA region. And I'm pleased to introduce today our speakers in the order of appearance. First of all, I have 𝗬𝗵𝗆𝗃𝗃𝗹, who is the sales manager of the GCC region at Jinko Solar. He has a total of 10 years of experience in the energy sector, including conventional and renewables sectors. Abdullah is going through an MBA in renewables with focus on solar, storage, and hydrogen energy. Next, we're pleased to have Sheam Yadav, the founder and MD of Clenergize Solar Consultants. He has grown the firm to be one of the leading solar consulting firms in the region with over 500 megawatts of projects in the GCC alone. The firm has grown in the last 5 years with several landmark projects such as Pepsi, Aramex, Emirates, among others. Before I hand over to Abdullah, I'd like to run a couple of questions just to get to know you better. If you please answer us from what industry you join us. If you work for a developer, an EPC, an energy services company or an O&M company or consultant, government, non-profit, academia. I see that most of the attendees today are from EPCs, consultants, governments. We have from academia, we have from contractors, developers. So we have a wide variety of attendees and you are all welcome. I know that this technology topic is very important for across the value chain in order to learn how to navigate through such a difficult market. The next question that I would like to know first, please, is to tell us from what country you join us. I would be happy just to know also like the areas of interest. I see that we have from the UAE, Saudi Arabia, Oman, Jordan, from the Levant countries, from Egypt, Algeria, Tunisia. So you're all welcome. If you are in the chat on social media, please write that in the comments. That would be great that we also use this opportunity to meet new people throughout the broadcast. So I'd like to take no further delay and give the chance for 𝗬𝗵𝗆𝗃𝗃𝗹 to introduce himself and to start and to share his screen. Hello, Abdullah. You're welcome.
Hello, Munif. Can you see my screen?
The screen, yes, but not yet the presentation. Yes, now we see it.
You can see my screen and my presentation now?
Yes.
Yeah. Thank you so much, Munif, for organizing this webinar, interesting webinar, where we will be looking at a case study done by Clenergize as one of the most important and active players in this market as a solar consultant in the GCC region. And thanks, Sheam, for accepting our invitation to be part of this webinar. So my name is Abdullah. I'm from Ginkgo Solar GCC sales team, and I'll be talking to you quickly today about N-type technology development, and then the key advantages of this technology. So we will just start quickly about the company, about Ginkgo Solar. So since 2000, so most of us know so far, most of the audience knows Ginkgo Solar as a solar major manufacturer globally, not only in our region. So since 2016, Jinko has been the #1 manufacturer in terms of global shipments, where we have shipped over 100 gigawatts by end of 2021, which has put us on a track of market share of almost 14.5% of the global market share by end of 2021. Our global manufacturing capacity of solar modules has reached more than 40 gigawatts, which makes us very resilient and very strong manufacturer to cover large projects and to cover the global shipments. So about our product portfolio, as many of us know, Jinko is a vertically integrated manufacturer, which means which is something that we're always proud of, that we manufacture the whole supply chain of wafers, solar cells, and also ingots in the beginning, and then until the PV modules. Also, we have added during 2021 two different product portfolios. The first one is the PIPV, where we have successfully delivered, or actually we started delivering the biggest project in the world so far, which is located in Dubai for 𝗬𝗵𝗆's headquarters, located in Dubai. So 𝗬𝗵, for the people who don't know, 𝗬𝗵 is the Dubai Water and Electricity Authority of the Emirate of Dubai in the UAE, and they're doing a new net zero building with their new headquarters. So we have been able to supply this project, which is considered the biggest project in the world of 5 megawatts of PIPV products. And also one of our very interesting solutions that we have also launched during Q3, Q4 2021 is the ESS, the energy storage solutions, where we can cover small residential projects to megawatt CNI projects as well. In terms of PV modules product portfolio, our mainstream so far is the P-type that we will touch on here in this slide, where we have a power density from 410 to 550 with our 163 millimeter wafers, 66 cells and 78 cells, which is called the Tiger product. And with our Tiger Pro products that we have a range of 415 up to 550 with 182 millimeter wafers, and we call this product as Tiger Pro. So our mainstream products for P-type are 163 cell size wafers and 182 cell size wafers. And so with N-type, which we are coming to, our mainstream, our product that we call, that the product name is Tiger Neo. So we have Tiger Pro, and Tiger Neo. With Tiger Neo, we have a product range of 430 up to 600 to 610 watt peak, with monofacial and bifacial, and all Tiger Neo products comes with 182 millimeter by 182 millimeter wafer sizes. So moving forward to N-type technology, most of us heard a lot about for the past 5 years, and also like 5 to 10 years, most of us heard about N-type technology in the market, mainly with the presence of the HGT technology, the heterojunction technology, which is also called, some of them call it HIT, heterojunction intrinsic thin layer technology. So the main issue with this technology was compared with the Perk P-type technology that has been developed for the past 5 years, was mainly the cost. The cost was really significant when it comes to you know, project financials and cash flows and, you know, initial investment, that also Shyam will cover on very like in details. So with our R&D capabilities, we have been able to break through to make a breakthrough in the technology, in the architecture of the cell size that we developed from P-type to Perk, and then to PERT as the first generation N-type, and then with the TOPCon as a second generation cell technology that we have recently launched. So moving on to the cell structure of to show, this is a quick presentation to show how the Perk cell, which is the passivated emitter rare contact cell structure, compared to TOPCon, compared also with the HGT technology. So we can see how with the different layers of every cell, how similar the Perk technology is to the TOPCon technology, which makes it very easy for us as a manufacturer to transit from Perk to TOPCon in our production lines of wafers and cells, where we can see here mainly the main added other than the N silicon substrate. We can see the main adder here is the tunneling layer, which helps the cell to have less resistive losses and less and to help more the carriers of electrons to move in the right direction. And compared to HGT, we believe HGT has a much more complex cell structure and manufacturing processes that really limits it to be competitive compared to TOPCon and Perk technologies. So moving forward to market share projections, many of us know that so many suppliers around the world are ramping up their capacities of N-type for N-type modules since 2022. So TOPCon is expected to dominate the market within the coming years up to until 2025. As you can see in this slide, how the TOPCon is projected by 𝗵𝗵𝗆𝗺 to have the biggest capacity among HGT, IBC, and HPC, and PERT as well. So, and also 𝗵𝗵𝗆Tech magazine estimates that by 2026, the market share of TOPCon will exceed 50%. So this is something that we are very proud of, that we are part of this transition to provide a higher technology and have higher limits, to reach higher limits as a PV modules manufacturer and developer of a leading developer of the technology. So here, this is a quick representation of how the efficiency of p-type compared to n-type evolved so much. So we can see on the top right how the p-type is limited to 24.5. This is the cell efficiency, okay, 24.5 compared to n-type, where you can see on the left how during 2021 Jinko was able to make breakthroughs and achieve new records in terms of cell efficiency and model efficiency, where in Q1 2021 we have achieved 24.9. You can see in the below 24.9 in terms of cell efficiency, and then we pushed to 25.25, and then by end of the year we reached 25.4 as cell efficiency, and also our module efficiency has been determined to have the potential or a theoretical new efficiency that can reach 23.5. So so in the bottom of this slide, you can see the limits, the theoretical limits that we see and the market sees and the research institutes see, comparing n-type with 28.7 as a theoretical potential limit that the technology can reach, compared to 27.5 with HIT, and also compared with the much lower Perk cell 24.5 as a limited cell efficiency that that manufacturers can reach. So moving on to the product and its key advantages. So mainly here that many of the developers and many of the EPCs and mainly like designers are always concerned on is a temperature coefficient, which plays a tremendous and very important role, a vital role in the MENA region, especially for the hot and harsh conditions that we live in. So basically, as you can see in the top right corner, how mono Perk and mono Perk half cell had a good improvement on the temperature coefficient. However, the improvement was a bit limited to 0.2, to 0.02, to 0.03. However, you can see with TOPCon, we have increased it to around 15%, from 0.35 to 0.3, which is something very significant for PV array designers like Clenergize and the other peers in the market. So also when you look at the power losses that you will have, you can see the black dotted, the blue dotted line is the TOPCon, compared with the red one is the conventional P-type, if you want to call it. You can see how the cell temperature. So usually the cell temperature is between 55 to 75, sometimes when during summer. So you can see that the minimum power gain or power loss reduction, if you want to call it, to be at least 1.5%, reaching to 3%, which is really considered significant losses that you can waive with N-type technology when you're using it on throughout the lifetime of a project. So here, last but not least, the main advantages that we are very proud of, that we always try to emphasize on in the market, other than the temperature coefficient that I touched on, is the much enhanced first year degradation at equal or less than 1%, compared to 2.5% with P-type, and also with the year-over-year degradation at minus 0.40%, coming from minus 0.55% on P-type. So that will, on long term, it's very important to always look at the 25 years or at least 20 years of generation, and see how both, and also that Sheam will enlighten us on it, how on long-term generation, how both modules are compared, and how the generation can be much more significant when you compare a P-type cell-based module with an N-type cell-based module. And also something very important for utility scale enthusiasts, the improved bifacial factor of 80%, 80 to 85% coming from on N-type, coming from 70 to 75%, which is also a huge improvement for utility scale projects. And also the last point that we also would like to highlight on is the low light performance, which is also very much enhanced with the N-type technology, where the cells can process and can regenerate power at much less irradiance during very early mornings and late nights. So in conclusion to my presentation, before N-type technology, we believe it is the future. Jinko Solar current capacity is 10 gigawatts out of 40 gigawatts, as I mentioned. We see it to be increased in the coming quarters, and we believe this product is going to be the mainstream, as it has proven to be an added value to the industry overall, and also for projects, utility and CNI around the world, from technical and commercial aspects as well. And one last thing I would like to mention, that we will look at, so many people will say, okay, the N-type is always more expensive than P-type. However, it should not be compared apple to apple in terms of prices. However, it has the decision on whether N-type or P-type is better for a project. It really has to go to detailed financial and cash flow analysis that will really show significant benefits to the project financial on the long term. This is the end of my presentation. Thank you so much, Munief. I'll pass it on to Sheam, who will talk to us about their case studies that they have done in one of their projects in Dubai. Sheam, the floor is yours, and thank you so much.
Thank you, Abdullah. Actually, you give us a smooth transition, like by ending at a very exciting point, talking about the economical benefit of migrating to N-type. And I think that is the core of what Sheam will be covering today. Thank you, Abdullah. And Sheam, you may share your screen, please. Thanks.
Perfect. We'll do that, Munief. Thanks, Abdullah. Thanks, Munief. I will just put my presentation on the screen. Let me know once you can see it. And let me know if you can see it well.
Yes, that's clear.
Is it okay, Munief?
Yeah, it's perfect.
Great. So thank you both for the platform and the opportunity to speak to you all about this product, because we come from a very technical standpoint as consultants in the market. I'll just give you a quick brief of who we are and what we do. Let me just hide all of this away so you can see the screen better. There you go. So we're a consultancy firm here, and we've been here for the past about 6 years. We came around when the solar market started picking up. So it's a team of designers, engineers, financial specialists, technically strong. We've delivered our projects in the region. Let me just annotate here. Yeah. So we're a solar consultant primarily, and we do owners engineering, lenders engineering. We basically prepare the tenders on behalf of end users, launch them in the market, collect the offers, negotiate them, do the legal contracts and supervision of projects. Essentially, we hold the hand of the client till the commissioning stage. So we've been through a lot of projects in the past 6 years to have some credible opinion on the matter of panels, inverters, structures, and cables, and what's working and what's not. So I'll take you to the next slide. Just to give you an idea, company's done about 550 megawatts in over 140 plus projects in the region. And this slide will give you a good feeler of the range and quality of our clients. When we say we've done projects in the region, most of them are sitting on rooftops of very well-known companies who have a very strong due diligence, and you probably cannot do any cheap or mediocre sort of installation on such clients' rooftops. And we're learning a lot as we go. So there's the range of multinationals for whom we work, and then regional clients and customers with industrial roofs. Most of our credibility comes from rooftop projects. And that's where I think this product will make a lot of sense, at least in the CNI region over here. So I'll go ahead now. And I'll tell you what we plan to do. Basically, Abdullah spoke of the product side of it. We come from the engineering and the design and the implementation side of it. So what's most curious for people like us is when you pick up the data sheets and the panel files, when you actually run it through the PV system and the installation on the site, what sort of numbers does the plant actually generate in comparison to an N-type versus an old N-type versus the usual P-type? So we decided to apply it to a running project. It's a 2.5 megawatt project in Dubai. We're designing it as we speak. We've used the old 545 P-type and the new 560 N-type. The available area, project parameters, cable trays, walkways, spacing, inverters, DC-AC ratio have all been kept same. Because these two panels have a very similar size, identical size, I should say. It's literally the difference between an N-type and P-type, and it's best displayed when you keep everything apple to apple. Costing is done based on present market pricing. You can discuss with Abdullah on the product pricing thereafter. But we've kept the BOS price similar and only tweaked the N-type versus P-type pricing. So I'll go ahead now. I've kept my presentation very brief, only 3 slides to come from now, because I want it to be effective. Very rarely do we have such a change in a product where improvements go into the double-digit percentages, sometimes single digits, higher single digits, and double-digit percentages. So between the P-type 545 and N-type 560, by simply the virtue of the higher efficiency, you get an additional 3% on kilowatt, an additional 3% on kilowatt, an additional 2% on the specific yield on a simulation basis. When the kilowatt goes up and the specific yield per kilowatt goes up, effectively the net energy goes up by 5%, is what we witnessed in this simulation. So simply within the same area, just applying the newer panel, you've got a energy gain of plus 5%, and this is not even considering the future performance for the next 25 years, considering the better temperature coefficient. So this, in our opinion, if you understand, if you've been in the industry, you know how competitive it is. Every percentage counts when you're in the tendering and quotation phase. Having an additional 70 kilowatts come out on a 2.5 megawatt plant simply by changing the panel is quite a big plus point here, considering how tenders are won and lost in the region. So this is on the capacity and yield. I'll go ahead to a more interesting slide. When we ran the commercials of this project, P-type versus N-type, the IRR jumps by about 3%. The rate of return of the project is plus 3% favoring the N-type 560. The return on investment in USD in 25 years is plus 9%. It's almost $1 million more. And this is where I wanted to stress on. Specifically for the leasing entities, when you additional $1 million USD or a 9% increase in the ROI of the plant allows you to give significant reductions in the lease tariff downstream to the client, or probably increase your own internal IRR commitments to your financiers, considering that you don't have to do any additional changes on the plant itself, because it's pretty much the same frame size and dimensions, and the BOS thereafter remains the same. Year 1 savings, in the end, you can see additional $22,000 US dollars per year, which is a 5% increase in annual savings. So even for the CapEx clients who really effectively see their payback and they effectively see annual energy saved per year, $22,000 coming additional from a plant, which is only a fractional amount of thousands of USD more in cost is quite beneficial, because this is going to be there every year. So there was one slide on the technical, there's one slide on the financials. It's plus 3% on IRR, plus 9% on ROI, plus 5% on the annual savings. I want to spend a little bit time on this one specific assessment that we did. Here we've compared in blue the new N-type 560 versus a P-type in orange, but you'll also see a gray, which is the old N-type. Why have we put this? There's a reason we're trying to direct your attention towards a point here. The old N-types used to be quite expensive. Now, we've done quite a few projects in the region where we actually deployed old N-type technology as well. I shouldn't call it old N-type, it is the usual market N-type. So we've deployed those as well. They were presumably costly compared to the P-type before, than the conventional panels. They used to have a very good output, they still do, and the plants with old N-type are actually performing quite well in comparison to P-type. So we thought we'll do a cumulative cash flow in USD, showing how the plants break even and what do they finally result in as the net position after 25 years. You'll see that the old N-types used to be more expensive, therefore definitely there's a $420,000 difference in a plant of this size had we gone with the older version of the N-type as compared to the Jinko N-type. So there's about a 420K USD difference on that front starting out. But what you see after 25 years is that the ROI benefit of the N-type is around $1 million USD. So what does this mean? The product coming out from their side presently gives us two very clear insights. It's cheaper or almost the same to build as a P-type in the beginning, and it gives you all the advantage of the N-type over 25 years. You probably only see a very thin difference between the lines, but you're talking in a range of $1 million USD, which is plus 9%. So for anybody who runs the financial numbers with the competitiveness in the market, specifically projects in Saudi, Bahrain, Oman, where the tariffs are so low, it will now be possible to even target industrial customers where it's about 18 halala as the tariff. The lease didn't make sense over there, but now with this technology and with this pricing, one can go well below that limit to even make that possible. So our objective was to put numbers and real simulations to the products coming from their side, and that's exactly what we did. The same 3 slides are shared with 𝗵𝗵. I think he can share it with you if you require. If there's any questions thereafter on this 2.5 mega, let us know, and we'll be happy to take your questions thereafter. So I'll rest my presentation at this point, 𝗵𝗵.
Perfect. Thank you, Sheam, for the insightful, short, but very informative presentation, and actually brings us to couple of questions that I have already received, so we could move to the Q&A section. And as you mentioned, the presentations are there, so you will be automatically redirected from Zoom to the registration page, but this time you will find the recording and the presentation to download right away after this session. So my first question is to Abdullah. We received a question on Facebook from the engineer 𝗬𝗵𝗆𝗃𝗃, who asks, could you mention the efficiency of the N-type modules, please? So what efficiency are we talking about commercially now, Abdullah?
Yeah, so far the product that we have to be in production is the 555 and 560 with an efficiency of 21.68 to 21.70, which is compared to the monofacial, the same product but P-type with an efficiency of 20.9 at 20.9 and 21.1 as far as I remember. But we can also share the data sheets with the audience to have a closer look on and compare both data sheets.
That's great. And we also displayed the emails of the speakers. And if you need that, also reach out to us. We'll definitely connect you with Abdullah and Shyam for that, for more details. And I would like to please ask you all to send the questions in the Q&A section rather than in the chat box, so we could follow these questions and answer them all. And if you are on social media, you may ask that in the comments and we will monitor that and answer your questions. Now, the next one is from Mr. 𝗬𝗵𝗆𝗃𝗵, and the question is for you, Shyam. Says, thank you for the interesting presentation. My question is, what was the discount rate considered in the cumulative cash flow?
The usual discounting we do is at 7% weighted average cost of capital. And that's probably the market standard unless the clients tell us otherwise. So it's 7%.
7%. Perfect. And then like a question to you, Abdullah, please. What is the price difference between the Perk and the TOPCon, and when would the TOPCon be available in the market?
Yeah, sorry, I was supposed to mention that in my presentation related to the differences. So basically, the price difference starts at 1.5 cent between P-type and N-type, but we wanted to also highlight on the differences on the long term, as I mentioned in my presentation, because we know a lot of clients, they try to compare apple to apple, and also always take the cheaper option. However, we always recommend before taking such decisions to make a detailed due diligence, work with have the opinion of consultants like Clenergize to understand exactly how this product will technically and commercially benefit the project. I cannot hear you, Munif.
Sorry, I've been muted. So now you spoke a little bit about the difference, and I'd like to ask then Shyam, please, to comment, like from your as a consultant.
Excuse me, Munif, I missed mentioning about the production. So the production starts by end of March. And our capacity is expected to it will start at 10 gigawatts, and so at 25% of our global manufacturing capacity, and is expected to reach 15 by the end of the year.
Okay, perfect. And then Shyam, based on what Abdullah said and the analysis that you did, is there like a minimum size of a project to use an N-type module, or do you see this applicable for all the sizes, like residential, CNI, utility? Any difference?
The answer is all in the numbers. It's pretty much a no-brainer at this stage, and you'll see the industry start adopting the N-type even for the smallest project or the largest project, simply because at a 1.5 cent difference, when you've got a 9% increase in ROI output, all the numbers for a small project or a large project will tend towards the N-type. And see, we come from a practical situation, practical standpoint here. We've got a lot of projects running on P-type. We've got about 5-10 running on N-type here presently. It is literally a better product when you see its output and performance, and when we plot these sensor graphs that we have of panels reaching probably plus 85 degrees here in the region. In the summers, we do reach 85. We reach 90 degrees here also. The output that we have on our old N-types are crossing 1750, 1760 yield on rooftops, which is phenomenal. You're reaching P-type yields around 1680, 1700, push it, but on normal average running N-type is crossing those. So in the long run, what I've shown you presently is a simulation. I start sharing data of the actual N-types and the performance here. We strongly stand behind it. We couldn't stand behind it before with the pricing, but with this level of pricing, it's a no-brainer.
But how much was the difference in price between the old type of N-type and the P-type in your experience?
See, the old N-types, which we've done projects, I think about 1 to 2 years back, used to hover in the range of the late 30 cents, early 40 cents, 42, 43 cents per watt. We've not seen any N-types come within the late 20s, early 30s range till now. And yeah, this is why I said in the beginning of my presentation, very few times in a webinar when we talk about products and design changes, is there something which is so disruptive where we've been waiting to see it, but the price point never matched. This is one of those times.
Okay. Thank you for that, Shyam. I think
Yes.
I want to also get Abdullah's input on the price topic, because we also
Yes.
have a couple of questions from also Mr. 𝗬𝗵𝗆𝗃𝗵, and I will merge it with the question from Mr. 𝗬𝗵𝗆𝗃𝗵. Both of them speak that they understand that the difference between N-type and P-type is at around 1 and 1.5 cents. They're asking if how much is reduced on the BOP side in percentage by obviously using more efficient module for similar sized projects. So like they would pay a little bit more on the modules, but how much do you think they would save on the BOS? And is that 1.5 cents a good ballpark to understand the price difference between P-type and N-type?
Yeah, I believe Shyam is the better person to answer this question, but I see that it really depends on the project setup, and because and it really depends on whether you have a size of a project, like a space. Like it really depends on the space restrictions that you have. So. It can be, you can have a higher energy produced with the same number of modules, but at the end of the day, it's really there will be definitely, because of the higher efficiency and the less number of modules that you can use. If you compare two, just like what Shyam did. In his presentation, they fixed the number of modules, and they compared how much energy and how much power you will be installing. So definitely there will be a price reduction on BOS, but I believe maybe Shyam can also share his thoughts and if he has numbers, but I believe it will definitely help on the BOS reduction.
Thank you, Abdullah. Any comments from your side, Shyam, on the BOS savings?
I was actually pulling out the BOQ sheets in the background because we were doing this estimation, and I'll answer that as directly as I can. So in between the 545 and 560, the dollar per kilowatt actually, because of the sheer gain of 80 kilowatts on the panel size, and everything thereafter is pretty much the same, because the cable lengths are the same, the cable trays and the walkways and the inverters and all the entire BOS thereafter is the same. Simply by upping the wattage of the panel, because it's the same frame size, your dollar per kilowatt actually hovers around the same range, if not by within plus minus $5 per kilowatt. So you've effectively eliminated the cost impact also within the pricing of the project itself. It will vary for certain projects where the fixed costs are the same. If there are more skylights, more trenching, civil works, car park, etc. On a pure rooftop project, you're hovering around the same range, if not by $5–10 per kilowatt. That's barely anything considering the yield advantage.
Okay, that's good information to consider, and I think justifies also the return on investment in the end improvement when you move to N-type on the long term. Then I want to ask the question to Abdullah next, please, because as you are moving into N-type, we've seen other players like LG exiting the market, and they were mainly supplying N-type modules. So, and they say that they had like supply chain cost difficulties and so on, so they exit the market. So how did you overcome this at Jinko Solar? And you're moving like mainstream into N-type, and you already mentioned that 25% of your production, like 10 gigawatts, is from N-type.
Yeah. So basically, as I mentioned in my presentation, and I'll emphasize that we have a very strong R&D team that are really walking hand in hand with the every development and every possible improvement. And as I showed in one of my slides the different structure of every technology from Perk to TOPCon and HGT. So we were, as I highlighted in the presentation, how our R&D team was able to make a slight difference in the structure of transiting from Perk to TOPCon by doing a slight adjustment on the cell structure, making TOPCon a simple way of a simple, if you want to call it, a simple cell structure coming from Perk, which made us flexible in terms of converting our production lines from Perk to TOPCon. Okay, so basically adding the tunneling oxide layer, and also with the N silicon substrate, it was easy. It was an easy, if you want to say, it was an easy transition for a major company like Jinko to move and transit from Perk to TOPCon. And when you compare it with the HGT technology, that was one of the main limits of those modules to be very expensive for CNI and utility projects, because of, as we believe, and also you can see it, you know, in the end of the day, the price of the product will dictate how complicated it can give you an indication of how complicated is the process of manufacturing such a product. And we also always saw N-type as a very, everyone has this perception that N-type is a very expensive product. We don't touch it. We are coming here with this technology. We're trying to prove that it's not the case anymore with the Jinko products. It's gonna be the new mainstream. It has higher limits. We have broken the code of how to make this technology with the same efficiency of the conventional N-type, and with the smaller premium on P-type.
Okay, perfect. And I want to follow up, please, on this question, because you mentioned the structural difference. And I have a question actually in that regard from Mr. Anand Satish, who asked, how does this structural difference affect the reliability of the modules compared to the P-type? So you have a well-established product, the Tiger modules, and then you move to N-type. Does this affect the reliability of the modules that you supply?
Definitely, none of our products will come online or come in production or come to the market without our stringent testing programs and our testing in our testing facilities, along with partners around the world like SGS and you know, and those guys to do, and TUV mainly, to do all the certificates, do all the harsh testings. And also one of the main programs that we do with the what's it called, one of the organizations in the US that we work with as well. I'm sorry, I forgot the name. We have done the PQP. We always
the PV lab.
Yeah, the PV lab and the PQP programs that we always scored the #1 manufacturer. So the same what we do with the P-type, we take the products from one stage to another in terms of testing before launching a product. We definitely have done the same with N-type, and we have deemed it to be a successful technology that will you know, that can be a mainstream to come.
Perfect. Thank you, Abdullah, for this answer. It is motivating, and I want to move this motivation to Sheam, and I want to see if you would confirm this positive vibe, or you have any concerns, because I remember back in the days before, I don't know, 5 years, when we all moved from monocrystalline, from polycrystalline to monocrystalline, and there was some rejection in the market in the beginning, some fears that this technology won't actually deliver up to its expected or promised performance it will degrade faster and so on. But as you see, the whole market has converted into monocrystalline. Do you see this happening also for the N-type? Do you see this market converting from P-type to N-type in the coming couple of years, the same way that the monocrystalline did?
There's a very easy way to answer this, Muniv. For sure, we see it. And within our team itself, guys are doing, I think, about 25 to 35 megawatts worth of designs every month. We've internally changed our complete PAN files and PV simulations to the N-type already. For a simple reason, like I'll tell you, when there was a shift from poly to mono Perk, there was some resistance. People understood it immediately within a year of them being deployed, that the output was pretty good. We went from the 1550 yield to 1640, 1630 yield practically. Then came a time where we went from frame panels to dual glass. And then these were dual glass without any frames. There was some resistance there. And as it turned out, it's sort of picked up for car park projects and aesthetic projects and then fizzled out. And then these dual glasses started coming with frames because of the cracking and the fragility issue. This specific panel, which is coming out now, probably doesn't have the same concerns because it's not that N-type didn't exist before. It's existed before. People have seen it with other brands and they've seen the benefit of it. We have. So we're not treating it like something new which is coming out. We're simply treating it like another brand has got the N-type now at a better pricing. We were all waiting for it. It's time to deploy it. As simple as that.
Mm-hmm. So, and do you, as a consultant, so you do recommend it to your customers, especially that if we're thinking about N-type and TOPCon as well, like as two new, let's say, technologies, do you encourage, let's say, your customers to deploy their plants with such technologies?
So we've already started doing it. In fact, we have a couple of NOCs going through DEWA presently in Dubai. And we have a lot of simulations for larger, like semi-utility, I should call it, 25, 50, 60 megawatt range projects. And the price point there, they were all trying to hover at around 16, 17 odd fills worth of PPA tariff. And when we started applying these N-types to that and running the simulations, we're able to drop a couple of fills on it. And that's already a very big advantage because these discussions really go down to the individual fill level when you're trying to sit with end users with projects of those scales. So we're definitely putting this across to our clients. They all have the same questions. Is this something new? Is it disruptive? Is the company backing it with the same sort of warranties as they have for other products? That's for Abdullah's team to satisfy our clients. We're pretty convinced on the simulation side of it. So we're already pushing it to our clients.
Perfect. Thank you, Sheam. Then this, as you moved it to Abdullah, I think I'll take this advantage and really ask Abdullah, as a new product, new technology, what guarantees do you provide to your customers to de-risk, let's say, this transition towards the new technology?
Munif, simply in the past 5 years, I believe you have. I'm sure you and Sheam also closely monitor the market, and you know how it has been evolving since 2017, from poly and then from mono, and then from mono to mono Perk, and then from mono Perk full cell to mono Perk half cell, where we had our Cheetah modules also. This has been discontinued. So with every beginning of a product, we faced those questions. We faced those challenges to why do you want to bring in this product? How do you guarantee this product will work? You know, and always, to be honest, we faced this for the first 3 months, 2 months, and then everyone wants to go on the new product. Because in the end of the day, as I mentioned, when you buy a new iPhone, you never question Apple how if the new iPhone is gonna really work or not, because at the end of the day, it's an evolution of a product, and we are not coming up with something new. We're enhancing the technology. We have big R&D teams. We have big R&D facilities that are running all year long to enhance the production and the performance of the product. So to be honest, I don't have a clear answer on that. However, I can always refer to the history of all the products that came online and how they all dominated the market for the years they were present in production. Your voice is off, Munif.
Sorry. I want to ask, please, because I've got a question from UAE asking when can we expect to get the authorities' approval, like DEWA approval in Dubai or in Abu Dhabi for the new Jinko N-type modules?
Yeah. Thanks for this question. We're working on the registrations. We're always been pushed by Clenergize as well on getting those registered. Our technical team are working on it. We're expecting them to be registered by end of Q1 of this year. So within a month or a month and a half.
Okay, perfect. And just like last question for you, because I want that we finish on time, but also like get all questions answered as much as possible. I have a question from Mr. 𝗬𝗵𝗆𝗃𝗵𝗵 asking the benefits of, I don't know, combining N-type cell technology with modules using quarter cell. So how do you, let's say, cut the cells for the N-type modules? Probably that's the question.
It's exactly like the half cell mechanism of cutting by laser. Maybe Mr. Saad is referring to third cuts that we see with the other peers. However, we have seen that those products came online during 2021 and then disappeared, where we believe they were not well tested, or they did not have the right feedback from projects or from other peers, product management, I believe. So we saw a third cut, and then third cuts were disappeared from the market, and we're sticking to half cells. So 2 cells, not 3 cells.
Perfect. Just then we confirm that it is half-cut cells that are being used in the new modules. Thanks. And I'll just a quick comment from your side, Shyam. It's a little bit out of topic, but this question has been repeated like 3 times from Mr. 𝗦𝗵𝗆𝗃𝗵𝗵, Mr. Abdullah Quram, and someone else asked, how do you clean these modules, like especially for the CNI sector, let's say in Dubai? Just a couple of words, like from your side. Is it manual cleaning, or do you have other solutions?
It's manual cleaning. Short answer is manual cleaning. You want to try robotics? We've tried probably between 12 to 14 brands in the last 6 years. We've tried them on rooftops, on car parks, not on concrete installations. Wherever the array size was between 3 and 5 panels wide, even 6 panels wide, we've tried robotics. There are very few companies we could probably discuss internally. I don't want to take names because a majority of them have failed. Very few have actually survived the test of time. The decision comes down to how much yield are you actually looking at getting from the panels. In a manual cleaning cycle, pushing 2 to 3 cleanings a month, you are getting in excess of 1730, 1750 yield here. If you leave it to the robotic cycle, you probably won't hit those numbers unless you add a mix of manual also, because you need water cleaning here. That's a definite. And even with water cleaning, you need to wipe off the last row of cells, because that's where, if there's stagnant water, dust will collect again and you'll get hotspots. So we've been doing this practically on the ground. 1 or 2 companies have actually proven helpful. But the longevity of these robots is where the concern is. There are 1 or 2 good companies, one of them from Saudi Arabia, which is doing a really good job in the R&D of it. But 85-90% of our portfolio is still manual cleaning, and the results are pretty good.
Okay, perfect. So, and with higher efficiency of modules, you use probably lower quantity of modules, maybe then you clean less in the end. So probably that's also something that would have a positive impact to save on labor and equipment, because this was also mentioned in the questions. Perfect. Thank you very much, Abdullah and Shyam. I'm sharing this slide just one last time. If you have more questions, or if you want to contact Abdullah and Shyam directly, especially because I've got some questions about pricing which I encourage you to contact Abdullah directly regarding pricing, and Sheam, if you have any, let's say, commercial technical questions and you need support from Clenergize in that matter. So thank you very much for this insightful presentation, Abdullah and Sheam. I wish to also thank the attendees on Zoom and over social media for staying with us for the full hour. And I hope to see you again in the future webinars with Abdullah and Sheam. This is not your first time with us on the webinars. I'm sure it won't be the last time. We always learn a lot from you in these sessions. We'll be so proud to have you on board. And again, I want to thank one more time 𝗬𝗵𝘆𝗺 for their support of this event. And I want to wish everyone on this call a sunny day, stay healthy and safe, and to see you the next time. Thank you very much.
Thank you so much, Munif.
Thank you, Abdullah. Thank you, Sheam. Thank you.